Hello and welcome to this GLOBEClaritas video presentation. Today I'll be going through some of the new features in the upcoming version 6.8 release of GLOBEClaritas, which should be out early July. The first new capability I'll discuss is the metadata / support files integration into the HDF5 datasets for better QA/QC and easier selection of input support files that you might want to use. So if I pull up one of our job flows, and I'll take the radon apply job. I won't run this flow because it'll take a little while to run, but if I open the old log file, there's a view last log file, and extend it out so you can see what's going on. You can see that now there's these dark blue sort of hyperlinked files that you can access. If you right mouse button click, you can see that you can open them with a suitable viewer. So in terms of a data set, I can open them with SV. Velocity files I can open with isovels or XSDE, or input them into the RMS application to remove bad RMS or interval velocities. So whatever support file is listed in here, I can select and view with the relevant viewer or editor. So you can see that even in history from the previous processing that's been applied to the input data, that these links are live and available for you to use. And then right at the bottom is the support file table that's written into the HDF5 file. And basically that defines what module created that support file, which can be a job flow or scale or mute or NMO dataset. And whether it's applied, removed, or just stored in the seismic trace header in case of the geometry data. So, as you can see, that allows you to track and identify what's been applied to your data, and also whether they're, in terms of velocities, whether it's still applied to the data or whether it's been removed later on in the flow. Understand which mutes or edit files are associated or applied with the data set. And so it gives you a good QA/QC process that you know exactly what's happened and at any given point to your data set. If I go to the Seismic Data tab and fire up SeisCat, and again within that data set I can basically, if I right mouse button click on a data file and say view segue file headers, again it displays the table of all support files that have been applied to the data set in that SLI display. I can also view and edit support files should I want to. So you see you've got a new application that brings up and displays the support file table interactively. If I right mouse button click, I've got a few options, so I can turn off and make the background plain rather than the striped version I've got there. I can, if I want to, remove a support file from the list if that's something I need to do. I can also change and hide some of the columns if I don't want them, so I can hide the MD5 sum column, for instance, to make the display a little less busy. And I can also add new support files into this table, which will be updated in the data set itself. So for instance, I can take the GNS pass2 velocity field and add that in. You'll also see that in this instance it defines that the user, i.e. me, has added this into the table. At the moment this velocity field is merely associated with this data set rather than actually being applied or stored in the trace header. So if I exit out of there, and in this radon apply job, if I then go add and NMO stack, NMO, and drop that in at the bottom. Then when I click on the list button to select an NMO file, it then gives me a short list of those those velocity fields that are associated with the data set that I'm actually working with. And I can, if I want to, which makes life easier if you've got a big project with lots of lines in it, to basically limit the velocity files or the mutes to only those ones that apply to the data set you're working on. If I want to go and pick a velocity field from the full set of velocity fields that are available, then I just click on the select from file dialog and it'll take me through to the standard file selection widget for within the velocities subdirectory of the project. But otherwise I can just click on what's being listed here and define that as my velocity field in there. So that's how it works within job flows, etc. So it's quite simple, and what we can do from SizeCat. That support file application is also available from the support files button in the launcher. Also, when we're using a data set in SV or CVA, which I'll use the CVA as an example, basically any velocities or mutes or trace edit files, for instance, that are created by those applications are also appended into the table of support files in the data set. So you maintain and update that as you go along and create new stuff. So if I use CVA as an example, pull that up, I will select the existing stack file that exists rather than regenerating. Just VO2, I go OK and OK, and I get my flow up. Got my semblance display. I'm going to pick a new field. I'm just going to pick a rough and ready velocity field, and then I'm going to go along adding more pics in as I go up the line. Then when I come to file, save and exit, it gives me the name of the velocity file I'm going to create. I'm going to continue to save, yes, okay, and it saves it out. If I then go to the Seismic Data tab, click on Support Files, and select Job 2 HF5, you can see that now appended to that list is a test video 2.nmo that's been created by CVA and is defined as derived from this data set rather than applied, stored, or removed. So you can see we're going to keep track of all these support files as we go through the processing flow, and either apply or create them from the data. And that way, when we then go into the NMO module and want to select a velocity field, we'll always have access to sort of latest and greatest generated data sets. So in terms of the metadata and support file methodology and technology that we put in, I think that sort of covers the main areas I'm going to talk about today. I'll also briefly talk about our new image K2d module, and I'll just show you the parameter form for this. So as part of an aim to retire the old pre-SDM module, our existing 2D pre-stack depth migration, we've created image K2d. It works in a very similar way as the K3d application and image K2t, so it's an MPI capable migration process. At the moment it's isotropic only. We will look at building in anisotropy into K2d and K3d as part of our future development. So we define an input HDF5 file. So if I take that, we give it an output name. We read in a velocity file, which will be our depth vint file, which we've created either as a horizon-based velocity model or a conversion of our RMS field from time RMS to depth vint. If it's a marine data set, we can just define that, yes, it's marine. Otherwise, if it's land data, we can actually read in a geometry database. We define the first and last CDP, as is standard in sort of K2d, etc. And our either if we're outputting a single offset or a stacked data set, our minimum and maximum offsets to migrate, or if we're outputting gathers, our first, last offset and our offset increment. The CDP distance between, if we're using a marine data set, between each CDP, 12.5 meters, and then standard parameters for our aperture, migration operator control are our range or aperture parameter, our protect, so our near offset protection, so we get that bottle shape on the operator, our angle to migrate, anti-aliasing if we want to apply anti-aliasing. So if we use a value of 0.0, then there's no anti-aliasing applied. Typically for most marine data sets which are fairly well sampled, and aliasing is not a massive problem, an anti-alias level of 1.0. For land data sets where aliasing and sampling of the wave field might be poorer, then anti-alias levels of 2 or 3 might be required. And then we also apply some additional tapering to the edge of the operator using the taper parameter. Incorporated in this as well are trace normalization and edge effect scaling as well, which is part of the things we've taken from our implementations in the K3d module into K2d and other modules in this release. And then we define the maximum depth we want to output, sample rate in depth in meters, so in this case default is 2.5 meters, and then our resolution of our travel time, so our velocity model travel times resolution, which is again defaulting to 25 meters. We can do it coarser or finer than that if we feel we need it. That should be reasonable to start with. And then we can define our MPI command and the number of cores that we want to migrate across. So along with that sort of new image K2d module, we've also done some additional work on the image K3d module in terms of adding anti-alias filtering, the trace normalization, edge effect scaling, and tapering capabilities to the operator, along with some speed up work. So now if you input data in shot order into the image K3d application, it'll run between 2 and 3 times faster than our initial implementation. We'll do some further speed ups along the way as we begin to develop and improve that application. And again, the image K2d module, again, we've implemented anti-alias filtering as per K3t and K3d, trace normalization, and edge effect scaling, as well as the tapering into that application. And some of that sort of trace normalization, edge effect scaling has also been implemented into the post-stack 3D Kirchhoff migration image 3D KP. So there's a lot of new functionality and capability within those modules worth testing. Whilst I'm here, I'll also talk about the angle times module, which is another one we've worked on. So basically, angle times is a module we've had for quite a while. It allows you to calculate angle mutes to be applied in the XT domain to seismic data. Whilst it worked really well, it was a little on the slow side. We've been hoping to get around to improving this for some time, but have always seemed to run out of time on releases. But this time, in our sort of tidy up towards the end of the release, we managed to work on angle time. So one thing we've done is change the speed up parameter defaults to 4.4, which will give you about a 2 to 3 times speed up on the standard run. So i.e. we'll take a 3-hour job down to a 1-hour job if you just use the speed up, if we just left it to this default change on the speed up parameter. We've then also done some further implementation where we just calculate the travel times for generating the angle mutes once for each CDP rather than for each individual trace. So consequently, we've got a fold time speed up for this module now. So i.e. if we took that 3-hour job and say it was a 10-fold job, with the speed up parameter we've already taken it down to a 1-hour job, and then with the further work we've done in terms of this sort of removing the over calculation of information within the flow, that's now taking it down from a 60-minute job to a 6-minute job. So as you can see, we've achieved some pretty good speed ups with this module, and I'll show you basically what the actual computed angle mutes look like. Let's go to CDP 600, somewhere towards the middle of the flow, and we'll overlay trace headers. And show you that. So basically what we have, as you can see, is our 5 15 and 35 degree angle mutes displayed on this data, and then those angle mutes can then be applied using the currently existing header mute module to actually apply the mutes to the seismic data should you wish to use them in your processing flow. So I'll quit out of there. Right, so now I'll move on, and if we change to projects to the 2D land tutorial, and I'll quickly talk about the SP-Stat2 module, which is new in this current release. So I'll open this job up again just because it's actually active at the moment. So the SP-Stat2 module, so the old implementation of SP-Stat2 didn't really work with HDF5 files, and also was quite slow when run on 3D datasets, as well as having no capability to filter or apply filtering or processing to the 3D datasets effectively within the job flow. So the SP-Stat2 implementation allows it to run directly from an input HDF5 file or CSEG-Y if you're still using CSEG-Y, and basically works in a similar way a lot of our other modules of being an input and outputting the final resulting shift files. So the parameterization is very similar to the original SP-Stat application in terms of how we define the windows, etc. But a lot more efficient, a lot better. And we know from benchmarking that some of our clients have done that generally the SP-Stat application produces superior results to other available residual statics packages that you can bring in to run with your software. So we'd certainly recommend that you test out this new SP-Stat2. It should be faster than the old one. Doesn't require the preparation job or the use of the DSOR SPS module, which can be quite confusing, and also can be run on larger 3D data sets. So whereas before we would have recommended using the ResStat application on larger 3D data volumes, we now say that you should certainly try the SP-Stat and compare it with the ResStat module and see which one you feel gives the superior results. Our expectation would be that SP-Stat2 should provide superior results in most situations. And what I'll do is as I've been running this job in the background, I'll bring up some of the results out of the SP-Stat2 module. So this is basically data with the resulting residual statics applied after the first iteration, second, third and fourth iterations of the SP stat. So you can see that we're getting an improvement between the first run and the last run within this flow. And these QC diagnostic displays, including the view shift display to show you the statics you're calculating, are generated on the fly by the application and launched when the processing flow finishes, such that you can QC and examine and see whether you're getting the result you're expecting from the data, as well as diagnostics being printed out within the processing flow itself to tell you how long things are taking and sort of the maximum sizes of shifts that you're creating at each point. So we think that the SP Stat 2 is a good improvement over what we had before, and also still leaves us with something that produces superior residual statics results than some of the commercially available options out there. And then finally, what I'll do is move to the statics application. We've also basically done some work on the 2D RefStat mod application at the moment, and it's only 2D RefStat that we've enabled this in to provide a linkage between the SV application and the RefStat module itself, such that you can update first break Pics on the fly whilst you're analysing your refraction statics solution. So if I show you how that does, so at the moment the standard methodology without this interaction between an update of first break Pics is accessed by clicking on the 2D RefStat button on the launcher under the statics tab. To enable the new functionality, it currently runs from the command line by typing in refstat -allow_reload, and it brings up the parameter form like that, and we'll accept that. And then if I pull this window to the fore, you'll see there's a couple of additional buttons on the right hand side of this display, which is the view seismic and the reload Pics. So if I click on the view seismic button, it will take our input dataset, our PC9608 JOM shots, and launch that in the SV application. And then what I can do is I can double click on a particular set of Pics, and it will go to those Pics. I can then, say if I click on the manual button, I can make some updates to the thing, to the Pics that I have, and maybe through there, say something like that. Oops. Okay, overwrite existing Pics. And then you see here that the reload Pics button has now become live, has a warning triangle to say that there's been some updates to Pics. And you can see that they change through there where I've made some changes. I could then run a iteration of updates, test, maybe 4 iterations. Look at the resulting corrections, and maybe I might decide that something looks a bit odd through there. And see, I can move to that area. I can then make my Pics, again updated here. So you can see there's now some linkage between the actual analysis of the first break Pics and creation of the refraction statics and the actual picking itself, allowing the user to update on the fly. the different Pics they've got and update and improve things as they go along. I could also go to, say, there and pick a new set of Pics on that thing, and again you can see it's requesting that I reload Pics. I can add those Pics in, and then I could iterate through the calculation phase. And you see, I've now got some more information in there. I could again go through and check or add in new Pics or update Pics where I felt they weren't great, and then iterate through, and hopefully generally that way make my resulting refraction static solution the best I can get it to be. So the reason we've enabled that only as a command line option at the moment is we'd like some feedback from users to see whether they feel it's robust and reliable, and if there's anything they'd like us to update or change at any point around this capability, it would be good to get feedback. So if you have a play around with that, as I said, from the command line, ref stat space minus allow underscore reload will give you that option, and you can start playing around with that functionality and see how well it works for you. That's the highlights for this upcoming release. We'd love to hear your feedback on all the different and new capability we've added in. So take a look, have a play around with the software once you've got it installed and downloaded if you're an existing Claritas user. And if you have any questions, contact claritas.support@gns.cri.nz and we'll be happy to help. If you're not a current Claritas user and you'd like to trial the software, then contact claritas.sales@gns.cri.nz and we'd be happy to supply you with a eval version for install and our tutorials and datasets for which you can use to play around with the software and learn how to use it and see if it provides the functionality and capabilities that you're after. Thank you for your time.